Let us understand what is angle of elevation and how do we solve problems related to angle of elevation. I am Anil Kumar. Welcome to my YouTube channel, absolutely free for the last 15 years, where you post questions, we provide solutions. Now, this series is especially meant for our GCSE students for whom trigonometry is a major portion. In this video, we will learn how do we sketch the diagram from a wordy word problem, and then how do we solve it in the best possible way. So let's begin with the question itself, which is a page long. Point H on a hot air balloon is sighted at the same time by two observers. One observer is at the top of a vertical building, point A, that is 156 meters tall. The other observer is at the base of the building, point B. The angle of elevation from point A to H is 40, and the angle of elevation from point B to H is 57. Point X is on the ground directly below H. Find the size of the angle AHB. Calculate the distance from point B to H. The hot air balloon remains at constant height as it moves further away from the building. Describe in words the change in the angle of depression from the point H to the point B as the horizontal distance between the balloon and the building increases. So you see, when you read such a long problem, the focus is lost as it like what are we trying to figure out. So it's important to highlight what you're reading and important things, right? So we're talking about point H on a hot air balloon is sighted at the same time by two observers, right? One observer is at the top of a vertical building. So one observer is at the top of the vertical building, which is 156 meters tall. Now the other thing which is there is angle of elevation from A and B. So angle of elevations from A and B is 40 degrees and from B it is 57 degrees, right? So that is critical. We need to find these things that we should figure it out. So now I hope you've understood the question. So let's move on to the next page. We have our critical information and let's sketch a diagram. So here again I have the whole information which we highlighted as a building 156 meters tall and two observers, one at B, who is on the building, right? A is on the building and B is at the base of the building. So A makes an angle of 40 degrees and B makes an angle of 57 to the balloon. Okay, so let's try to sketch it. So let's say this is the building for us, right? Now I'll just make ground like this. That is the ground for us. So 40 degrees angle from the building for the balloon. So let's say this is 40 degrees angle, and here we have a balloon, correct? Okay. From the base, the angle is 57 degrees. So let me just connect from base to this place also. Good. So angle of elevation is the angle with the ground, right? From the ground, it's kind of a angle of a side. Okay. So for us, let's do this dotted line. And this is 40 degrees for us. And here, this angle is what is 57 degrees. Clear? So you understand angle of elevation. Angle of elevation is along the side with the horizontal. Is that clear to you? So angle of elevation. So angle of elevation with horizontal along I side, as you see, right? Now, the other term commonly used is angle of depression, which will be from the horizontal looking downwards. Normally, it will be same as angle of elevation. Alternate angles, you get the whole idea. Okay, great. So we have the diagram here. Let's label it. The height of the building is given to us as 156 meters. Correct. We need to find, let's label A, B, and H. And point X is on the ground, so X is on the ground. So this is the point X on the ground. Means 90 degrees. Correct? So I think the diagram is absolutely clear. We can now solve it. Right. So we have to find this angle. That is one thing we have to find. And second thing which we have to find is, let me write down what we need to find. Angle AHP. And the second thing is we need to find the length B to H. Correct. So these are the two things which we need to find. Right. Then we have a communication question. So let's move on to the next page and answer this. Okay, great. So we have a building which is 156 meters tall, right? Right. So I'll again sketch what we had done there, and then so we have this diagram right there. Great. So that is a part of the building, and we have these two angles. 40 degrees, 57, and this height is 156. Great. ABH. And this is X, make 90 degrees. Now, first part is to find angle AHP. So that is this angle. Correct? Angle AHP. I'll show you how do we find it very easily and how another student will find it with lot of work. So let's go with lot of work first, right? So if this is 90, this is 57, let's find this angle. That angle will be, let's say we are say angle BHX, right? So angle B will be on 180 minus 57 minus 90. You can say 90 minus 57. One way, correct. Second, what will you do? You will extend this, right? Let's say this point is P. Then that is also right angle, correct? So you can find the angle AHP, which will be 90 minus 40. Correct. So we found that angle. You get the whole idea. And now the required angle, which is AHB, is difference of these two, right? Is angle AHP minus the angle BHX. Correct. You'll get the answer. So these are three steps to be done by a normal student, correct? How are we going to do it? Let's try to understand. So you see, I had already shown that we could draw a line here, right? This line is parallel to the base, and therefore we know this angle here also is 57, correct? Now that angle AHB, is an interior angle, right? And 57 is the exterior angle. So 57 degrees should be equal to, let's call this angle AHB plus 40 degrees. You understand this part? Now this 57 degrees is the exterior angle. Exterior angle is equal to sum of remote interior angles, right? So let me find the answer here and then so AHB is basically 57 minus 40. which is 17 degrees. You get the whole idea. So simple, right? So this is 17 degrees. Minimal amount of calculations to get your right answer. Now you could do the other things and you'll get the same thing, correct? So what did I use here is the concept that exterior angle is sum of remote interior angles. So 40 and the other angle are remote interior, away, right? The third one is 180 minus 57. So that is so simple as that. Easily you can find. And this particular concept is used in many questions. So it is not just saving three steps here, but it is saving three steps in most of the questions. Great. So we got that angle. Now we can move on to the next part of the problem, which is we need to find B2H, right? Correct. So first part is over. I think that is absolutely clear. Correct. So we have that angle as 17 degrees. How do you find B2H? So let me again sketch the whole diagram. See, there's no harm. I'm just sketching this diagram again and again to make you understand that, these are simple figures, right? Correct? So that's the balloon, right? This is the point A, this is B, and that point was given as H, this was X, correct? Correct. And we have this part also connected B to H. Now we need to find what is BH. We know now the angles, which is given to us as 40, this is 156. This is 156, 40 degrees, 57, and this is 17 degrees, correct? Now, how do we find B to H? Couple of ways to do it. We could actually, we'll use sine law here, right? Sine law. So for that, we know this is 90 degrees, correct? So angle at A is 40 plus 90, 130, right? So we know that the angle HAB is 90 plus 40. And we know 17 degrees is the angle at AHB. We know the side 156. We need to find HB, right? So I normally write the side which we need to find on the top, HB, over sine of angle opposite, which is sine of 130. 40 plus 90 equals to 156 over the angle opposite to 156 is what we found, sine of 17. You get the whole idea. So HB is equal to 156 times sine of 130 over sine of 17 degrees. Let's use the calculator, figure it out. 156 times sine of 130, correct? And we need to divide this by sine of 17. 408.73. So B to H is 408.73. So we can approximate this as, because this height is in meters, is 408.7 meters. Is that clear to you? So simple. Once we find that angle, use sine law. Correct? Now let's move on to the communication question. In GCSE, the questions are given in parts A, B, C, D, and so on, and they are very wordy, just as this one. Okay. Now it says the hot air balloon remains at constant height as it moves further away from the building. Describe in words change in the angle of depression from the point H to the point B as the horizontal distance between balloon and the building increases. So let's try to understand this. So once again, let me just sketch the ground here. Building, balloon, right? Okay. So this was 40, right? 57 degrees, right? So now what is happening is this balloon is moving right, but at the same height, 400 odd, which we just figured out, right? The question is, as it moves, what is the angle of depression, right? So let's say if it moves now, what is the angle of depression? Angle of depression is the angle which is made with the horizontal line. You get the whole idea? So let me draw this as a horizontal line, right? So at present, the angle of elevation and they are normally same, right? So it was 57. As I move further, you see this angle decreases, right? This angle is much smaller. Let's say this is another distance, h dash. So you will notice that the angle with the horizontal decreases, right? So angle of depression. Angle of depression is kind of like this. You understand? Like this angle with the horizontal. Let me just extend this line. Not this angle. Correct? So this angle, earlier it was this. You see that? You see the difference, correct? So the angle of depression decreases as the distance, which we mean horizontal distance, correct? Increases. You get the whole idea, right? So that is how you can write down your answer, right? Even the angle of elevation, as it goes further away, decreases, right? From the point B in this case, right? So I hope this is absolutely clear. We went through the statement, highlighted the important things, and then we made the diagram absolutely clear. We also learned while moving along that exterior angle is sum of two interior angles, and that's a efficient way of solving such problems of finding angle. And any trigonometric equation where sine law or cosine law will be used, this is must to know. Once you know that, you know the angle. Now it's a candidate for sine law. Since we have a combination of angle and side opposite known to us, I mean, or not known to us. Here, this is known to us 17 and 156. Once you have this combination, we can always work out sine law. As shown here, we have rounded the figure to one decimal place and got our answer. So I hope these questions are answered perfectly well. Feel free to write your comment, share your views. Also note that we have a very important Global Math Institute website where you can see some special offers for our lessons and special rates for summer registration of courses. Feel free to send an email on globalmathinstitute@gmail.com for my classes in summer, which will be discounted heavily. Thanks for your valuable time, and also look forward to my new book, Crack the Numbers, which will be soon in the market. Thank you, and all the best.
Who is this book for? Middle and high school students who want to go beyond the classroom? Future STEM leaders looking to develop problem-solving and analytical skills? Anyone who loves math and wants to see its real-world applications in AI, physics, and engineering?
Are you ready to explore the mathematics of the future?
Crack the numbers for future STEM leaders. Sharpen your skills, shape the future. Available soon. Visit our website to pre-order your copy and unlock your mathematical potential today.